AI feels almost weightless. You open a chatbot, type a prompt, wait a few seconds, and something useful appears. An email, a summary, a bit of code, a plan. From the user side, it looks simple. Behind that answer is one of the heaviest businesses in tech. Chips, servers, cooling systems, data centers, electricity contracts, land, fiber, and billions of dollars spent before the money fully comes back. That is the real AI spending war. And the big question is no longer just who has the smartest model, it's who can afford to run AI at scale. Quick note before we get into it. This video is for education and context only. It is not financial advice. For most people, AI is software. For Microsoft, Google, Amazon, Meta, NVIDIA, and the cloud companies around them, AI is becoming an infrastructure race. The key layer is compute. Training large AI models takes huge clusters of advanced chips. But running those models every day may become the bigger long-term cost. That running cost is called inference. It's what happens every time the model answers a user. Training happens in big bursts. Inference happens constantly. Every prompt, every AI search result, every coding request, every generated image has a cost behind it. That is why the spending numbers are getting so large. Microsoft has said its AI business reached an annualized run rate of more than $37 billion. That is real revenue. But the infrastructure bill is also huge. Alphabet raised its 2026 capital spending guidance to between $180 and $190 billion. Meta moved its forecast to between $125 and $145 billion. Amazon has been linked to a 2026 spending plan around $200 billion, much of it tied to AI infrastructure and AWS capacity. These are industrial numbers, and the clearest signal is NVIDIA. In May 2026, NVIDIA reported $81.6 billion in quarterly revenue, up 85% from a year earlier. Its data center business was the engine. That shows where the AI boom is landing first. GPUs, memory, networking equipment, racks, cooling, and the systems needed to make AI run. Big tech is building AI factories. NVIDIA sells many of the critical machines inside them, but chips are only part of the problem. A GPU needs a facility around it. It needs power. It needs cooling. It needs backup systems. It needs engineers. It needs a grid connection that can handle the load. And this is where the story gets more physical. Electricity is becoming one of the biggest constraints. The International Energy Agency estimated that data centers used about 415 terawatt-hours of electricity in 2024. By 2030, that number could more than double, with AI as the biggest driver. A large AI-focused data center can use as much electricity as 100,000 households. Some of the biggest facilities can use even more. So the problem is not only buying enough chips, it's getting enough reliable power in the right place, with permits, cooling, transformers, construction labor, and time. That is why tech companies are signing power deals, looking at nuclear, exploring geothermal, buying renewable energy, and choosing data center sites around grid access. Compute is becoming a power problem. For users, that may show up in very normal ways. Free AI tiers may become less generous. Usage caps may get tighter. The best models may stay behind paid plans. Some tools may become more expensive if demand keeps rising, and inference costs stay high. There is another pressure building too: debt. The largest AI companies still have huge cash machines. Search ads, cloud contracts, enterprise software, e-commerce, and social advertising give them enormous room to spend. But on 7th of July, Amazon moved to issue at least $25 billion of bonds. MarketWatch reported that AI-related corporate debt sold off as investors made room for the deal. That does not mean the AI build-out is falling apart. It means investors are asking harder questions. How much more infrastructure does this company need? How quickly does that spending turn into revenue? How much capacity is sitting unused? Because expensive infrastructure has to be used. A data center full of AI chips is a powerful advantage if customers are waiting to rent the capacity. If demand arrives slower than expected, that same infrastructure becomes a problem. That is the quiet pressure behind the AI boom. The spending happens now. The payoff has to arrive over years. AI demand is real. Companies are using it for coding, search, customer support, analytics, design, office work, and infrastructure management. The sharper question is whether every part of the AI economy can justify the amount of money now being committed to it. Some of this build-out will probably look obvious later. Some of it may be mistimed. So when a company announces a new AI model, don't only ask what it can do. Ask what it costs to run. Ask who pays for it. Ask whether the company can turn impressive demos into repeatable revenue. The key AI metric over the next few years may not be a benchmark score. It may be utilization, how much of the expensive hardware is actually being used, and how much cash it produces. That is where the real AI race is moving. If you want grounded breakdowns of AI and tech without the hype cycle, subscribe to Aurus. And tell me in the comments which company you think is making the smartest AI infrastructure bet right now.